Hi, welcome to your first AP Chem video. It's awkward, I know. You'll get used to it. We'll do these all year. For those of you who AC, you'll love it because you'll be able to figure out what you missed without feeling like you missed a whole class period. You'll be able to watch it at home. Sometimes even if you are in class, you'll be able to watch, like maybe there was something you didn't understand, or I went too fast, or you came in late and you want to go back and see what you missed. And then obviously for summer homework, I don't have access to, so I'll try to make videos before school's out this year to get you started so that we're sure, that you're getting the information you need, okay? So, little technical glitch there. Let me make sure we're back on track. So, all right, the first thing I wanted to point out to you is the periodic table, which hopefully you're all pretty familiar with. This is the official copy of the one you'll be given for your AP test, okay? There's two resources you'll be given. You'll be given this periodic table, and you'll also be given a formula sheet. I'm going to encourage you to become as familiar with that formula sheet as possible as we go through the year, so that every time we do a unit that relates to the formula sheet, you can look at it and be like, oh, that's what's on there related to this. So then you know how it's useful. The periodic table, here's something I want to point out to you. They only have the symbols. They don't have the names, okay? So there are times where maybe you're going to have to know the name of that element so that you know where to find it. If it has a symbol like Ag, for example, which probably most of you know is silver, you know, like it would be useful for you to know those off the top of your head so that you're not thinking that like Si, which is silicon, is silver instead, okay? Now, do you have to memorize all the elements and their symbols and their masses and all that? No, you don't. Most of the time, the AP test will give you that information that you need, but again, it's like for all of the summer work, just so you guys know, the more you understand it and the better grip you have on it from the beginning, the easier your life will be as things get harder, okay? So it's important that you're familiar with the periodic table. All right, so one of the things that I want to take the time for us to look at here is I want to make sure that you know the group names, okay? Because that's important. So keep in mind, for example, whoa, that's really big, that first column there, those are called the alkali metals, okay? So you just, you want to keep fresh on these things that are on the periodic table so that you know what they are and you're not getting confused, okay? As many of you know, when it comes to ionic compounds, which we'll talk about more, are compounds that are made of ions, right? And so in ionic compounds, the alkali metals have a charge of +1, all right? We are going to need to be familiar with charges. Again, this is one of these things that the faster you know them off the top of your head, the more time we're spending moving forward than having to backtrack and be like, wait a second, what's the charge on that again? So try to use this time over the summer to actually remember, okay, these are the alkali metals, they're +1. All right, and then as many of you know, right next to them, and I'm going to make that a little smaller, those, column 2, are the alkaline earth metals, okay? So that's the alkaline earth metals right there, okay? And they have a charge of +2, okay? Metals are always positive because they lose electrons, which means they have, like the alkaline earth metals, for example, to become an ion, they want to be like the noble gases, okay? So, for example, beryllium wants to be like helium. In order to do that, because helium has a complete outer energy level. Like the 1s level on helium is full because it has 2 electrons, so it has 1s2. For beryllium to be like helium, it needs to get rid of 2 electrons, and it has an atomic number of 4. So that means if it gets rid of 2 electrons, it has 4 protons, 2 electrons, so it has a positive 2 charge overall. So that's where the charges come from. Okay, so your alkaline earth metals are your +2s. Okay, these groups over here, all right, just keep in mind that they're named after the element that's at the top of that column. So group 13 is the boron group. 13 is the boron group. 14 is the carbon group. 15 is the nitrogen group. 16 is the oxygen group. And then when you get over here, and I'll change colors, to fluorine, okay, this group, as you know, this group is called the halogens, okay? And the halogens are nonmetals, all right? And nonmetals typically have negative charges. So all the halogens have a charge of -1. And the reason that their charge is -1 is because, again, like, everybody's trying to be like the noble gases, because the noble gases have complete outer shells or 8 valence electrons, which is the goal, okay? So because the noble gases have 8 valence electrons, the halogens only have 7. So what do they need to do? They need to gain 1 to be like the next door noble gas. So fluorine has 9 electrons. It wants to gain 1 to be like neon. If it gains an electron, then it has 1 extra electron. It has 10 electrons and 9 protons, which is why it would have a -1 charge. And that's how that works for all of the halogens. Okay, and then lastly, group 18, just so you're aware, group 18 is, again, like we just said, but I'll write it on here anyway, just so we're consistent, the noble gases, okay? So group 18 represents the noble gases, all right? So those are the 4 special names, okay? You'll notice on here, I just want to make you aware that the staircase is not drawn on here, okay? So you might want to become familiar with where the staircase would go. It always starts to the left of boron, and then you just draw it all the way through, because that staircase represents your dividing line between metals and nonmetals, okay? Most of the things on the staircase are considered to be metalloids because they have properties of both metals and nonmetals. But aluminum, for example, is technically on the staircase. However, as you know from daily experience, aluminum has all the properties of a metal. So even though it's on the staircase, it still gets classified as a metal because that's how it behaves. Okay? So that is our rundown on the names of the groups and some qualities on the periodic table.